Hello everyone and welcome to my YouTube channel. Today we are going to build a PDF chatbot. Today we are not going to use OpenAI or ChatGPT or any other libraries that obfuscate a lot of code. We are going to write the code on our own for the preprocessing part, and we are going to use only two libraries. One of them is PDF Miner and another one is Sentence Transformer. So let's get started. So let's import ArcParse because we want to be able to build this and chat with different PDF files, and you can easily extend this code to all kinds of documents. And from PDF Miner dot high level import extract text. And I should also mention that I have already coded this today morning, and the code is right in front of me. So I do have a reference. I'm not doing it from scratch. And from sentence transformers, we will import sentence transformer. And we are also going to import cross encoder and util. I'll let you know what cross encoder and util is. In the previous video, I've shown you the text generation inference. That's what we are going to be using today. So I'm using the Python client for text generation. So you can just do pip install text-generation and you will be able to install this. And we are going to be using the Docker server for text generation, and I've already shown you this in the previous video. So if you don't know about it, take a look. Anyways, you can just use what I'm showing you today. So let's define a function called pargars, which is the argument parser. So I will say parser is argparse.argument parser. And here I'll have two or three different parameters that I can adjust. So parser.add argument. Here let's add a parameter called fname, which is the file name. Type is string. Required is true. Okay, so we got this argument fname, and let me just copy this. And now we need another argument called top-k to choose the top results. Top-k, and this is int, and instead of require we can just do default equal to 32. So we got this top-k argument. And now we need another hyperparameter, let's say window size, int 128, and let's copy this one, step size. So we will discuss all what these arguments are. Okay, and return parser.parseargs. So if I have a main function now, here I can do args is parseargs. Okay, so now this is like the very basic stuff just to start with. Now we go to something interesting. So we define a function called embed. Embed will take arguments like file name, so fname, window size, and step size. Okay. So here we are going to be, first of all, we are going to read the text. So we are going to use pdfminer.6. This is a library maintained by collaborators of PDF Miner. So you can install it using pip install pdfminer.6. So this is what I imported here, extract text. So extract text and fname. So it's just going to extract all the text for me, and I think you can do it in much better manner, much more complicated way, but this is how I'm going to do it. Dot join text dot split. So what this function is doing is just removing all the white spaces and converting it to a single space. All kinds of white spaces, including new lines and stuff. And then I extract all the tokens with a simple split function. So text.split. So now I have all the tokens. So what I'm going to do is I'm going to create a list of sentences. And you can call this paragraphs. So for each sentence, what we are going to do is we are going to have a window size and a step size. So let's say we extracted the first 100 tokens. Now the next sentence that begins starts with 80. That is the step size. So 20 tokens are common. So let's create an empty list, sentences, and it's much clearer when we write the code if I'm not able to explain properly. And it will also be clear when we see an example. So sentences for I in range 0 len of text tokens, and here comes step size. A window is text tokens I plus window size. If len of window is less than window size, break the loop, and sentences dot append window. Okay, so we got all sentences. So this is a list of lists. All sentences are in tokens. So I will say paragraphs equal to but join s for s in sentences. So I again have combined all the sentences with the space. So I got the paragraphs, and now I can now we can just quickly print paragraphs and see, like, are we getting something good or it's just a crazy function. So here I can run embed args.fname args.window size and args.step size. Great. Okay, let's quickly run this, and you see, like, I have a PDF file here, and this PDF file is one of the latest papers called Hyper Dream Wooth. So obviously all the chatbots that exist right now, they don't know about this paper. Let's go to terminal, and here I can do Python, what was the name, chat.py, fname is the file name, the PDF file name. Okay, the function object has no attribute, parse args. So parser.parse args. Okay, it should be here. Parser.parse args. Okay, now it should work. And it has generated like a everything from that PDF. So let's go to the beginning and see if it's working as expected. So here starts the first sentence, or the first paragraph, whatever you want to call it, and I think it ends here. And the second one starts from that are then two refined using fast fine tuning for high fidelity, and this is here, that are then refined using fast tuning for high fidelity. Okay, so it's keeping an overlap. and it also has a lot of new tokens in the subsequent sentences, and that's what we wanted. Okay, so now comes the fun part. We need to create embeddings. So to create embeddings, we are going to use sentence transformer. So I'll just say model sentence transformer, and my sentence transformer model is sentence transformers all MPNet base v2. So you can use any kind of model that gives you embeddings. You can also use Bert and Robert. Just take the average of all the tokens if you want. And I will set the model.max sequence length to 512. So anything beyond this will be truncated. So you can also make your sentences in such a way that it fits. Then all the sentences will be encoded. And I'll have another model called cross encoder. Now what cross encoder is doing here? Encoder slash ms macro mini lm l6 v2. Ooh. Okay, so we got our model, and we also got our cross encoder. So model is so now we create the embeddings. So embeddings is model.encode paragraphs show progress bar to true. Okay, so this will create all the embeddings that we need, and here we return model cross encoder embeddings and paragraphs. Okay, I will let you know what cross encoder is used for. Just give me some time. Okay, think we are fine. So now we have our embed function, which is creating the embeddings, and we can also like here print embeddings.shape, and we can run this code and see what's happening. And if you're doing it for the first time, it's going to load the model, but it's really fast. Yeah, okay, still printing all the paragraphs, and okay, mini lm l6 v2. Did I make a mistake in the name? Let me quickly take a look at my reference. Mini lm l6 v2 cross encoder ms Marco. It's not macro. Marco. Okay, ta-da. Try again. Okay, yeah, sure, it seems to be working. So it created 60 different paragraphs from this paper, which is not very big, and embedding size is 768. Awesome. So now it's time to search. So I will just remove this print paragraphs, and here we can create another function called search. Now what the search function is doing, it's going to take a query and find you the closest matches based on the sentence embeddings of the query using cosine distances, similarity. So here you have the query, you have the model, and the cross encoder, you have embeddings, passages or paragraphs, and you have top K. Okay, so my query embeddings can be generated by using the model.encode, query. Here we forgot one thing. Let's convert it to tensor, PyTorch tensor. Okay, so my embeddings are available as PyTorch tensor. Query, convert to tensor equal to true. And now we move the query embeddings to CUDA. Query embeddings is query embeddings dot CUDA. And then we do the semantic search. Now, sentence transformer has utils and it has a semantic search function, so we don't need to write it from scratch. So I'll just do hits is util dot semantic search. And here I have question embeddings or query embedding and the corpus embeddings or just embeddings here, and top K is top K. Okay, so we got our hits, and now we need to, since we have only one query, we can just add 0 here. So we got hits for the first query. Now comes the use of cross encoder. So now you have the hits by semantic search of our query and all the paragraphs that you have. So this will give you the top K results. In our case, we are going to set it to, I think we have set it to 32. So we are going to get 32 results. And then we are going to use cross encoder to re-rank them. So we create an input called cross input for cross encoder, and which has query, paragraphs. Paragraphs have which paragraphs we want. We want only those paragraphs which are our hit. So hits, corpus ID, so that's the index. For hit and hits. Okay. So we have created a list of tuples, a list of lists with query and the search results. We create all the pairs. So cross scores. So now the cross encoder model is going to create a score for query and our hit. So we can refine the results or re-rank the results. So cross encoder dot predict, and here we have cross input. So we have now created a score, and now we can use only the top 5 results. So results is a empty list. Hits, let's sort the hits. So sorted by sort hits by key equal to lambda x, and you have cross score. Okay, so now your hits are sorted by cross score. Okay, I think we forgot one thing. We need to add the cross score to hit. Okay, for idx in range len of cross scores, we will say hits idx cross score is cross scores idx. Okay, so now our hits are sorted by cross scores. And I can now do for hit in hits 0 to 5, taking top 5 results, and I will append it to results.append. Here I can write paragraphs, hit corpus ID, and I'm also going to replace all new lines. I don't think I have new lines, but let's just do that. /n with space and return the results. Okay, let's try this now. So we got our embedding shape, that's fine. And my search results. Let's do a loop. While true, and inside the loop we can use the input. So print /n and query we can get from the user, input, enter query, or anything you want. Okay, and results will be search. Here we have the query, the model, cross encoder, we have the embeddings, so all the inputs basically, and top k is args.topk. Okay, so in the first function we create the embeddings for all the paragraphs. First we extract all the paragraphs, then we create all the embeddings. In the second function we query those embeddings using the query embeddings, and we create top 32 search results, and then we re-rank the results using the cross encoder. And here I can just do print results. Okay, so let's try this part. Okay, so now it's creating the embeddings. Now it says enter query, so I can just do hyper dream booth paragraphs. Crap. So we got top k, we also have paragraphs. Embeddings paragraphs is paragraphs. So query model cross encoder embeddings paragraph, query model cross encoder embedding paragraph top k. Okay. Hopefully it works now. Dream booth. Okay, great. So now you see like you're getting search results. It's a list of 5 different paragraphs. Sorted by cosine distance. Awesome. So we got the results. We don't need to print it anymore. And now we create a prompt. So I'll say pre-prompt is, I'm just going to copy paste this part. Okay. So we just added a pre-prompt. Below are a series of dialogues between various people and a bot. You're knowledgeable. You should give correct answer. Don't let caution get too much in the way of being useful. Ends with a /n. Then I have a prompt, and here I can write okay, context. Okay, so I've written here, use the following pieces of context to answer question at the end. If you don't know the answer, just say that you don't know. Don't try to make up an answer. Don't make up new terms which are not available in the context. So we have the pre-prompt, we have the prompt, and now the fun part. The fun part is, on my local machine, I can only run 7B Falcon, but I also used Hugging Face inference endpoints to deploy Falcon 40B model on 4 T4 GPUs. So we will be using both the models. The model that we will be using locally. So let me just start the model. Okay, so here we are, Docker run. I'm using a single GPU, port 3000, the data folder, log level, blah, blah, blah. And here the model is Falcon 7B, instruct model, but trained by Open Assistant. And let's just run it. Okay, it says that it's already running, but anyways, let's try. Okay, so now it's starting. And if you want to know about this part, this is text generation inference, so you need to check out my previous video, but it's just this Docker command, so nothing else. You just run the Docker command. And now I have a 7B model running on my local machine. Okay, what I'm going to do now is, now I'm going to create 2 end prompts. So one called end 7B, and this one looks something like this. Slash n, slash n. Then I have the prompter. And then I have the query, which is your search query. Then I have the end of text token, and then the assistant token. And end 40B, it's because Open Assistant was trained in a different way. And for 40B, what we can do is we can do slash n user. Then I have the query. Then a slash n. And then I have the Falcon, what Falcon says. Okay, we got all these stuff. And we also need some parameters for text generation. So we will keep the parameters common for both the models. So I can just write the parameters here. These are my parameters. Temperature, top P, top K. You must be used to all these parameters now. Stop sequences. I have added the end of text token for 7B model, and I have also added end of text token for the 40B model. And you know that I have already imported the text generation client, so I'm going to create 2 different clients. One is the 7B client, and one is the 40B client. Yeah, don't worry about this URL. I'm going to close the endpoint after this video anyways. So now we have the query, we have the results, and now what we want to do is we want to send the request and see how the response looks like from both different models. So I can say query 7B is pre-prompt plus prompt dot format. Here I have context, and my context is slash n dot join results, and my and then I have query 7b plus equals and 7b dot format query equal to query. So I have formatted the queries that I will be sending as input for 7b client, and then we're going to do the same for 40b. Okay, everything else is the same. So end 40b is not defined, or what? 40b. Okay. Okay, so now we can just generate the stream. So I can say, okay, text is nothing. For response in client 7b dot generate stream. Here I have the query for 7b, comma, star parameters. Okay, and here I say if not response dot token dot special text plus equal to response dot token dot text. Okay, so this generates our response from the 7b model. So I can say print /n 7b response and print the text. And similarly, I just copy paste all this. I should have made a function, but anyways, client 40b, here it's 40b again, and this is the 40b response. Okay, I think we are done. We don't have to do anything else. So let's try to run it and see. So we already have our Docker container running here locally, and I also have an endpoint on AWS with bigger GPUs running the 40b model. So let's clear all this. And let's see, Python, what was name? Chat.py. Fname is the PDF. It's a latest paper. Okay, so let's hope it works. So it has encoded and it's now asking me to enter a query. So what are is Hyper Dream Boot? Let's see the responses. So 7b response has been quite fast. It's from my local machine. So Hyper Dream Boot is a hypernetwork architecture designed for text to image. Combines deep diffusion neural networks. I think it's also generating few things which are not in the paper. So hypernetworks was first introduced. Hyper Dream Boot was first introduced. It was first introduced in the paper that we have. And this is the 40b response. Hyper Dream Boot is a hypernetwork. I think this is more precise, right? So I can also ask is Hyper Dream Boot faster than Dream Boot? Let's see. 7, yes. So I mean, after years I shouldn't have so many sentences, but yeah, it's a 7B model, and oh yeah, 40B gives a very good response. Hyper Dream Booth source code has not released yet, so it's not possible to compare, but in the paper they mentioned that it is faster. How many images do I need for Hyper Dream Booth? The number of images will depend on several factors, including complexity. We found Hyper Dream Booth requires 20-25 images to improve. So this is actually not correct. You only need 1 or 2 images, and this gives me the best answer. You would typically need at least two images or more. What is Hyper Dream Booth based on? So it's based on hyper networks, and I think now the 7B model is again writing a few things which are probably not in the search results, but yeah, we wait for the 40B model's response and see what it says. Yeah, it's taking quite some time. Unofficial Stable Diffusion Guide to Personalizing Diffusion. It uses transfer learning techniques. I think that's more or less correct. But anyways, so this is a video. You can easily extend all this code to any kind of document, multiple document, and you don't have to go for obfuscated code, because here you know exactly what is happening and it doesn't take a lot of code. I have I think, yeah, like 100 lines, 120 lines of code. You can make it even smaller. So this is it, and you can try with different kinds of sentence transformers. You can try with different kinds of search functions. You can use databases to store these vectors and then query those databases instead. But the basic idea is going to remain the same. You can use any different kind of pre-processing. I have not applied a lot of pre-processing. You can extract tables and ask questions for tables. You can do anything you want. You just need this basic code. And as you can see, like, even the open source model from Falcon, the Falcon 40B instruct model, is giving me quite good results. And the best part is everything is offline, or let's say everything is private, so your data is not shared with anybody. I think in few days or a few weeks, open source models are going to beat the closed source models anyways. So I hope you liked the video. If you did like it, do click on the like button. Do subscribe. If you have any questions, please feel free to ask in the comment section, and please share the video with your friends, and see you next time. Goodbye.